6.7. We're talking inequalities here. Okay, we focus mostly on equations. Now we're talking solving inequalities. You'll notice it talks about solving inequalities algebraically and graphically. So we'll talk some algebra, but then we're also going to talk graphically in terms of using the graphing calculators. Okay, so definitely something you'll want to become confident with. Again, if you don't have access to a graphing calculator when you leave school, there is an app on the phone you can look up. Okay, Calc84 is one of them. There might be others. Just take the name of the calculator and search it and see what you can come up with. But they work equivalent. We can talk about that sometime in class when I remember too. But first type of inequalities we're going to talk about are absolute value inequalities. I don't know that we talked about these in Algebra 2 last year. So if the absolute value is less than A, then it is an AND inequality. As opposed to if the absolute value is greater than, then it is an OR inequality. So we talked about those last year. My little trick is when you see the less than sign, you kind of emphasize it. It's a less than sign. So you're always going to use an AND when you write this statement. As opposed to if it is a greater than sign, well, now you change it into greater. And so that's always an OR statement. When we're setting up these inequalities with absolute value, you have to think what's inside that absolute value could be positive or negative. And so that's why we set up two statements. The first statement is always as is. The second statement, we change two signs. We reverse the inequality sign and we change the sign of the number or the value. So positive becomes negative. Okay? So let's look at example 1. Example 1, the absolute value of x minus 4 is, what's that symbol? Less than?
3.
Less than 8. So when you see absolute value in inequalities, always make sure your absolute value is by itself first. In this case, my absolute value is the only thing on the left side. So I'm going to say write two inequalities. The first one is as is, dropping the inequality or the absolute value. So x minus 4 is less than 8. It's a less than sign. Do I put an and or an or word in between them?
And.
Less than means we're going to have an and statement. And whether you're doing and or, the next piece is the same idea, is that you keep whatever's in the absolute value as is. So we're keeping the x minus 4. The inequality sign is going to reverse, so less than becomes greater than. And the positive 8 becomes negative 8. You do the opposite of whatever's on the right. Okay, we've got two basic pieces to solve, yes. I doubt you need me for those. If it's x minus 4, I'm going to add 4. X less than 12. And if it's x minus 4 over here, I'm also going to add 4. And now I have x greater than negative 8 plus 4 is negative 4. Now, and statements. We don't traditionally leave with the word and. We traditionally write those as compound inequalities where they are one statement. Remember what I'm talking about here?
The x is...
X is in the middle.
Yeah, and it's the both less than signs.
Both less than signs.
The negative 4 is less than x. Or less than...
Okay. So it only works for and statements. It does not work for or, but it always works for and statements that x less than 12, you see x less than 12, and x greater than negative 4. Well, reversed, x greater than negative 4 is negative 4 less than x. So and statements, you always put the x in the middle. It'll always be two less than signs, assuming you get your smallest number on the left and your larger number on the right. Now, I don't remember what directions are going to say. However, if you recall when I talked about this, I would like you in the habit of doing interval notation. Okay, right now this is an inequality. How do you write this same thing in interval notation? I don't have that you need to graph it on here, but a graph might help.
It would be -4.
What's this graph look like? If it's x less than 12, that goes where? The left of 12, and 12 is going to have a parenthesis. If it's x greater than -4, to the right of -4, and a parenthesis. Remember, and is where do the graphs overlap? So the graphs are going to overlap in between. It's called an intersection there. If you need that visual, there's your help. What is this in interval notation then?
-4.
Yeah. My graph interval starts at -4, comma, and it ends at 12. Both cases have a parenthesis. So there's the answer I'd be looking for on homework. Obviously, I'm going to expect some work with it. Questions there? Okay, example 2. Got a new inequality to solve. Absolute value again. This is a greater than. So greater than means when we get to that point, we're going to need the word or. What do I have to do to start this problem, though?
Distribute.
Not distribute. Before we can set up our two inequalities, we need to make sure that our absolute value is isolated by itself. Is my absolute value by itself on the left side of this inequality? No. So think of it. It's 2 times something minus 3. What are the steps I take to get that absolute value by itself?
Add 3 and divide by 2.
That's what I'm looking for. So we're going to add 3. If I add 3, I now have 2 times absolute value of 3x minus 2 greater than or equal to 10. And side note, we traditionally don't distribute into absolute value. It's not that you can't, we just traditionally don't. Okay? And then the other step to get this absolute value by itself was to, it's 2 times the absolute value, divide by 2. So absolute value of 3x minus 2 is greater than or equal to 5. Once you have your two pieces or your absolute value by itself, now you can set up 2. The first one, as is. Just drop the absolute value. So 3x minus 2 greater than or equal to 5. I just said greater than, so we're using the word or. The second one?
3x minus 2.
Okay, still 3x minus 2, but greater than becomes less than, so less than or equal to. Positive 5 becomes negative 5. And you have the two inequalities to solve. If it's 3x minus 2, we're going to add 2. So 3x greater than or equal to 7. X greater than or equal to, gosh darn it, can't get this to squeeze in there. 7/3, there we go. So x greater than or equal to 7/3, or what? 3x less than or equal to negative 3. So x less than or equal to negative 1. Again, I'm looking for interval notation. There's your inequality. If you want to, you can throw it on the graph. And just, I don't remember. You only have to do graphs if it says so. But what's happening with this graph here? X greater than or equal to 7/3 goes to the right. What am I hitting? Okay. So to the right of 7/3, and 7/3 has a bracket. Less than or equal to negative 1 goes left of negative 1 with a bracket. Do you remember how to do this interval notation? Where does my first shaded interval start at?
Oh, negative infinity to negative 1.
Starts at negative infinity, comma, and ends at negative 1. Infinity is always used parentheses. This was equal to, so we're using a bracket. Now, you could, in my notes I have the word or. You could also use that U symbol, the union symbol. Where's my second set of shading? Starts at 7/3 with a bracket because it's equal to, comma, infinity. Positive infinity with a parenthesis. Okay. Remember, traditional and shading is usually in the middle between two numbers. I say traditional, usually. I can't say 100% of the time. Traditional or shading is either or. So it's anything that, you shade, doesn't have to overlap, and it goes out. Okay, let's review, yes? Okay, the rest of this lesson talks about solving quadratic inequalities. So now, instead of talking absolute value, we're talking about quadratics. We're talking about our U-shapes, our parabola shapes, right? A quadratic inequality is solved by first solving the quadratic equation, so equals 0 instead of using the inequality symbol. That's going to give you two solutions. We then use our graphing calculator to check and see which numbers would be greater than or less than the numbers we solve for, so depending on what you want to look at. So, start by just thinking about x squared minus x minus 12 equals 0. Okay? If you're solving this, just in your brain. In other words, not with the calculator is what I'm saying on this piece. How do I solve this with our brains? What? Two parentheses. It factors, doesn't it? This factors into x squared. X squared is x and x. Multiplying to be negative 12 and adding to be negative 1 is going to be negative 4, positive 3. Officially, how do we keep going? I know a lot of you just jumped to the answers at this point, but officially I'm going to say set each factor equal to 0. So x minus 4 equals 0, or x plus 3 equals 0. Solve each of those. We have x equals 4, or x equals negative 3. If we just wanted to look at the equation, there are solutions. And if we just look at the graph of this parabola, those places are going to be where the graph crosses the x-axis. Okay, so your solutions when you set an equation equal to 0 like that are when my graph crosses the x-axis. Now, it didn't ask me for when my graph crosses the x-axis, because it didn't ask me for equal to 0. It asked me for what? greater than 0? Where are y values greater than 0? Positive, meaning we're going to be looking above 0, which is the x-axis. Okay, that's going to be the key, is where's my graph above the x-axis. So we started off graphing y equals the x squared minus x minus 12. And then the question you're going to ask yourself is, where is the graph above the x-axis? This is where my timing is just slightly off. Does anyone graph this? What are you finding if you graph it? It's a parabola that crosses the x-axis at -3 and 4. Okay. Not necessarily the right idea. I mean, that's the gist of it, yes? Yes. So we're looking in reference to -3 and 4. Where is my graph above the x-axis? So where's the graph above the x-axis? To the left of -3 and to the right of -4. Can you guys get on board with that? Okay, because we're looking in relation to -3 and 4. So to the left of -3, to the right of 4. So when x is greater than 4, or when x is less than -3. Okay, those are the pieces we're looking at for our answer. Now, if we put those in terms of interval notation, it's 4 to infinity, and -infinity to -3, which I would normally write in the other order. Okay, we will pick up here tomorrow. Make sure you have graphing calculators available tomorrow, and we'll talk about how we'll also transition how to do these on the calculator. Okay? Homework, you could look a little bit at it, but it will not be due tomorrow because we will finish notes tomorrow.